which of these functions is odd? And so just let's remind ourselves what it means for a function to be odd. So I have a function, well, they've already used f, g, and h, so I'll use j. So function j is odd if you evaluate j at some value, so let's say j of a, and if you evaluate that j at the negative of that value, and if these two things are the negative of each other, then my function is odd. If these two things were the same, if you didn't have this negative here, then it would be an even function. So let's see which of these meet the criteria of being odd. So let's look at f of x. So we could pick a particular point. So let's say when x is equal to 2. So we get f of 2 is equal to 2. Now what is f of negative 2? F of negative 2 looks like it is 6. F of negative 2 is equal to 6. So these aren't the negative of each other. In order for this to be odd, f of negative 2 would have had to be equal to the negative of this, would have had to be equal to negative 2. So f of x is definitely not odd. So all I had to do is find even one case that violated this constraint to be odd, and so I can say it's definitely not odd. Now let's look at g of x. So let's look at g of x. So I could use the same, let's see, when x is equal to 2, we get g of 2 is equal to negative 7. Now let's look at when g is negative 2. So we get g of negative 2. G of negative 2 is also equal to negative 7. So here we have a situation, and it looks like that's the case for any x we pick, that g of x is going to be equal to g of negative x. So g of x is equal to g of negative x. It's symmetric around the y, or I should say the vertical axis right over here. So g of x is even, not odd. So which of these functions is odd? Definitely not g of x. So our last hope is h of x. Let's see if h of x seems to meet the criteria. So if I'll do it in this green color. So if we take h of 1, and we can look at it even visually. So h of 1 gets us right over here. H of negative 1 seems to get us an equal amount, an equal distance, negative. So it seems to fit for 1. For 2, well, 2 is at the x-axis, but that's definitely h of 2 is 0, h of negative 2 is 0, but those are the negatives of each other. 0 is equal to negative 0. If we go to, say, h of 4 is this negative number, and h of negative 4 seems to be a positive number of the same magnitude. So once again, this is the negative of this. So it looks like this is indeed an odd function. And another way to visually spot an odd function is a function, it's going to go through the origin, and you could essentially flip it over on both axes. So if you flip this, the right half over the left half, and then flip that over the horizontal axis, you are going to get this right over here. So you see here we're going up and to the right, here we're going to go down and to the left, and then you curve right over there, you curve up just like that. But the easiest way to test it is just to do what we did. Look at a given x. So for example, when x is equal to 8, h of 8 looks like this number right around 8. H of negative 8 looks like it's pretty close to negative 8. So they seem to be the negative of each other. Sounds like a car crash just happened outside. Anyway, hopefully you enjoyed that. Not the car crash, the math problem.